Hi, Mr. Richards here. Today's lesson is in solving inequalities by multiplication and division. First, we're going to address the multiplication property of inequalities. Let's just write down two random numbers here, such as 5 and 2. Well, we know that 5 is greater than 2. But what happens when I multiply both of those by a positive number? Well, if I take my 5 and I multiply that by, let's say, 3, and I take the 2 and I multiply that by 3, what is my result? Well, 15 and 6. And I still have 15 being greater than 6. Nothing's changed. But what if I take the same 5 and 2, and 5 is still greater than 2, and I multiply both of those by a negative 3? A funny thing happens. 5 times negative 3 is negative 15. And 2 times negative 3 is negative 6. Well, it's not greater than now. Negative 15 is not greater than negative 6. Negative 15 is less than negative 6. Now, this example illustrates the multiplication property of inequalities. This states if both sides of an inequality that is true, 5 is greater than 2 is true, are multiplied by a positive number, the resulting inequality is also true. And that's illustrated in the first example where we just multiplied by the positive 3. But if both sides of an inequality that is true, again, 5 being greater than 2 is true, if these are multiplied by a negative number, the direction of the inequality sign is reversed to make the resulting inequality also true. And that's what we did up here. We had to reverse it from a greater than to a less than to make it true. And that's what we'll be practicing today. Matt walks at a rate of 3/4 mile per hour. He knows that it is at least 9 miles to Onks Lake. How long will it take Matt to get there? Write and solve an inequality to find the time. Well, if he's going 3/4 miles per hour, we can say, all right, that is 3/4 times the time, and then we have our 9. Now, what inequality symbol can we put in there? Well, that's going to be greater than or equal to, because if it's at least 9 miles, well, it can be more or equal to. Basically, at least 9 would be 9, 9.5, 10 miles. but he's going 3/4 miles per hour. So it's 3/4 times the time is going to equal our distance. Now, how do we solve this? Well, multiply by the reciprocal. If we multiply by 4/3 on both sides here, that cancels. And we're left with t is greater than or equal to, and if we do a little bit of cross-simplifying here, it'll result in 3 times 4 is 12. So our time is going to be greater than or equal to 12 hours, so it will take Matt at least 12 hours. Now we're going to solve each inequality and graph the solution on a number line. Well, negative 3/5 d is greater than or equal to 6. Let's multiply again by the reciprocal here on both sides. The reciprocal would be negative 5/3. And this cancels out. And we're left with d. Now we have to reverse the inequality since we're multiplying by a negative number on both sides. So we're going to reverse the greater than or equal to into a less than or equal to. Might as well cross simplify here to make things a little bit easier. And 2 times negative 5 is negative 10. So d is less than or equal to negative 10. What about 2/5 d is less than or equal to negative 20? Well, again, multiply by the reciprocal on both sides here. And once again, this cancels out. And we're left with d is less than or equal to, but wait a minute, there's a negative number and we're multiplying. But look at what's being multiplied on both sides. The 5/2 that we're multiplying on both sides is positive, so there is no need to reverse the inequality. So we're going to keep it less than or equal to. Let's go ahead and cross simplify here. And negative 10 times 5 is negative 50. Now we're also being asked to graph these on a number line. So to sketch the number lines, what I typically do is I'll put the number to my solution in the middle, and then a number smaller and a number bigger. And then we'll start with an open circle, but realize, okay, this is or equal to. That means I need to fill in my circle. When you see the line underneath the inequality, the or equal to, that means you do need to fill in your circle. Now, we're looking for all the numbers that are less than or equal to negative 10. Well, ask yourself, is negative 20 less than or equal to negative 10? Yeah. So you're going to shade in that direction. Is 0 less than or equal to negative 10? No, so we're not shading that way. And we can follow the same principles here with the negative 50. Negative 50 somewhere in the middle here. Number bigger. Number smaller. Well, actually reverse that. Number smaller, number bigger. And then we'll start with our open circle, but this is or equal to. So we're going to fill in the circle. And negative 60 is less than negative 50, so we'll shade it in that direction. Since negative 40 is greater than negative 50, we will not shade it in that direction. Let's continue on. Now, what about the division properties of inequalities? Well, let's once again start with just a random example here. What if we have 15 is greater than 5? What if we take that 15 and 5 and divide these by 5? Well, 15 divided by 5 is 3. 5 divided by 5 is 1. And 3 is still greater than 1. So again, when we're dividing by a positive number, it does not appear to change anything. But what if we take those same numbers, 15 is greater than 5, and instead of dividing it by a positive number, we divide it by a negative 5. Well, our result, 15 divided by negative 5 is negative 3. 5 divided by negative 5 is negative 1. And negative 3 is less than negative 1. Again, notice how our sign is reversed. So, for our division property of inequalities, if both sides of a true inequality are divided by, we'll shorten this one up here. We'll say a positive the resulting inequality is true, but if both sides of a true inequality are divided by a negative number, the direction of inequality sign is reversed to make the resulting inequality true. And if you're looking at this and going, well, that looks a whole lot like our multiplication properties of inequalities, you would be right. So let's look at two more examples. Our first one, 12k is greater than or equal to 60. Here we're going to divide by that 12 on both sides. And our result is k is greater than or equal to 5. And if we go to graph this, have our 5, number smaller, number bigger. Start with an open circle, but this is or equal to, so we shade in that circle. And then we test, is 0 greater than or equal to 5? No, so we're not shading that way. Is 10 greater than or equal to 5? Yes, so we're going to shade it in that direction. What about negative 8q is less than 136? Well, let's divide by the negative 8 on both sides. That cancels, and we're left with q, and this is where you need to recognize I'm dividing by a negative number on both sides, so we're going to reverse the inequality into a greater than, and 136 divided by negative 8 is negative 17. So q is greater than negative 17. And we can go to graph this one. Number smaller, number bigger. Start with the open circle, and this is not going to be shaded in since negative 17 is not greater than negative 17. It's not a solution, so we're not shading it in. Also, there's no little line underneath it, so it stays open. Then test your numbers. Is negative 20 greater than negative 17? No, so we're not shading that way. Is negative 14 greater than negative 17? Yes, so we are shading in that direction. And there's our solution. Now there's also a way to check these inequalities. You could, say, put in the negative 20 in for q in the original. So you could say something like, okay, negative 8 times negative 20 needs to be less than 136. Well, negative 8 times negative 20 is 160. And 160 is not less than 136. But if we tested negative 14, negative 8 times negative 14 is 112, and 112 is less than 136, so that is true. Just other ways of testing inequalities to make sure that they work. That is it for this lesson. Good luck.